Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to go ahead with the chapter Sequences and Series of First Year PUC. So let us mention the chapter name. Where we can expect 6 plus marks. Okay. Now let us try to recall some of the basic things, nothing but the definition for sequence, then progression. So let us first understand what is sequence. It is an arrangement of element in a particular rule, whereas progression is a sequence in which each element obeys a particular pattern. Now moving on to the example on sequence. Let us suppose that we have got some numbers to be arranged in a pattern. So 1, 3, 5, 7, 9 and so on. Okay. Let us suppose the last term is something like 21. Now I want to know the location of this. So as you can see, this is the first term. So we write this as A1. This is the second term. So we write as A2. This is the third term. And ultimately this is what? Nth term. So the index which is given here, no, those are what? Going to specify where the particular element is present. Where that particular element is present. Similarly, this is what? Fourth term. So the location of 7 is 4. The location of 21, this is the last term, so AN. AN stands for last term, sorry. AN stands for the last term. Now having this, first thing is to be understood, if I talk about any nth term or a general term, n is always a natural number. So when we are solving the problem also, you will see that this suffix index n value is chosen such a way that the output is always a natural number. You may have now something like an is equal to an minus 1 plus an minus 2, which we call Fibonacci sequence or series. As soon as I'm just giving a plus sign there, we say series in place of comma. You can see comma is given here. It is separated by commas. Now, coming to this, surely when I want to talk about the location, see here, it is n minus 1 and here it is n minus 2. So surely the condition will be specified as n is greater than or equal to 2. If I give 2 minus 2, 0. So it should be strictly greater than 1. Sorry, strictly greater than 2. So that this, as soon as I say strictly greater than 2, the next natural number will be 3. So here A3 and here 3 minus 1 will be 2 and here 3 minus 2 will be 1. So always a natural number. So this type of condition will be seen whenever we write a sequence. If there is no condition given, so surely the number will be starting from 1. Okay. Now, let us try to also understand what is a series. As soon this sequence is given, in place of giving a comma in between them, if I just write plus sign A1 plus A2 plus A3 plus A4 and moves on ultimately to the last term, this we call series, where commas are replaced by plus sign, and in short we write this one as summation A k. K is running from 1 to n. This is sum of first n terms, which we also denote by Sn. What's the meaning of Sn? Sum of first n terms. If I write S7, what's the meaning? I am adding first term, second term, third term, up to where? Seventh term, because 7 is there. Always start from first. Now in this we have got types of sequence and types of series. Just finite and infinite. Now coming to finite sequence, if the number of terms are finite in number, nothing but countable, only then we say it is finite sequence. For example, 2, 8, 11, let's say last number is some 30. Okay. Whereas infinite sequence will be, which is not a sequence which is not finite. For example, same example I'll take here 2, 8, 11 and just dot dot I give. In this itself, no, one more example you see 2, 8, 11. I know the last term 30 and again I give dot. As soon as I give 3 dots, it's nothing but, and I have not mentioned the last number, it moves on, it continues. And I want to highlight one more point, that when I'm going to write like this way, both are different, they are not same. It's not chapter 6 where the order is not important. Here order is important. In sequence, order is important. Order of element is important. Order of element is important. Okay. Now similarly, coming to series, we have got finite and infinite series, just depending on whether we have finite number of element or infinite number of element. So coming to series, finite series. See carefully. So the same, I just write 2, then plus 8, plus 11, then moves on, last number is 30. Again, coming to infinite series. What we are going to have? See carefully. First example, second 2 plus 8 plus 11 moves on. Okay. Similarly, no, the corresponding second example for series. Just see in place of comma, I've given plus sign. Next, 2 plus 8 plus 11 moves on, plus 30 and moves on. Let us suppose that I have got a series having both plus sign and minus sign, alternate plus and minus. For example, 2 minus 8 plus 11 minus say some 15 and moves on. This we call alternate series. Alternate series are those in which the signs are plus minus. Okay, like this. So having understood this, let us move on to the problems. Okay, kindly make a note. Dear students, let us move on to 1 marker problems from sequence and series. From each of the model paper, 1 marker question is asked direct from with respect to location of the term. The question says here, the model question paper number 2, as we are aware, this model question paper are issued in the year for the academic year 2024 to 2025 from PU board. Now, question says the 5th term whose nth term is the nth term. An stands for nth term. Just now we discussed the concept. We want 5th term. So if I take this as equation number 1. So since in the question they ask 5th term, so put n is equal to 5 in this equation number 1. So if I do so, we are going to have a5 is equal to here 5 times of 5 plus 2. So 5 into 5 plus 2 will be 7. 5 sevens are 35. 35, option W is correct. Okay, very easily we can get 1 mark. Now coming to model question paper number 1, I have just written the particular order. Here they have given nth term and find a particular term. But see this, sir. For the 4th term from model question paper number 1, the 4th term of the sequence defined by first term is 1, second term is also 1, and here they are given one sequence, a particular way of writing. You can see an is equal to an minus 1 plus an minus 2, where n is more than 2. Okay, we have to find the 4th term. Now see, if I put n is equal to 4 here, if I put n is equal to 4 here, I write it here, an is equal to an minus 1 plus an minus 2. Since in the question they said find the 4th term, if I put n is equal to 4 in equation number 1, which is this, we are going to have a4 is equal to 4 minus 1 plus a4 minus 2. 4 minus 1 is 3 and 4 minus 2 is 2. So I want the second term and third term addition I have to take to get the 4th term. But I have been given only first and second term. So this is very clearly saying that second term, yes, I have got here, but third term I have to find. So here I am going to take, I'll take this as again equation number 1. So put n is equal to 3 in equation number 1, so that I can get what? The third term. So if I put here in 1, we'll get a3 is equal to a3 minus 1 plus a3 minus 2. 3 minus 1 will be 2. Then 3 minus 2 will be 1. A2, second term. You can see both second term and the first term, both are what? 1 itself. So 1 plus 1 will be nothing but 2, and that is our third term. So third term is 2. So I can substitute this, I'll take as equation number 2. From equation number 2, the third term is 2 plus the second term is 1. So 2 plus 1 will be 3. So the fourth term is 3. The fourth term is 3. Option D is right. Now, let us move on to question number 20. If the sequence question says, if the sequence an is defined as first term is 1 and nth term is equal to n minus 1 term plus 2, where n is greater than or equal to 2, then find the third term. So again, coming to the solution, this is a fill in the blanks 1 marker question. This is also a 1 marker question, but it's an MCQ based. This is also a 1 marker MCQ based. Now, see this. an is equal to an minus 1 plus 2. Now here you can see n greater than or equal to 2. Why this condition is given? If I put n is equal to 2, you can see here what has happened. What's going to happen here? Just see first. I'll get a2 here is equal to a. 2 minus 1 is 1 plus 2. If the condition is given, no, like n is greater than or equal to 1, then see what happens. Put n is equal to 1 here. This will be first term, and here 1 minus 1 will be what? 0. I get a0. Location of the term starts from 1, but we have already discussed. So always our n is natural number. So this condition is given such a way that if I'm going to put the value, the index should not be 0 nor be negative. Same thing you can see here also, that they said n more than 2. Why it is more than 2? Why it's not equal to 1 nor equal to 2? If I take n is equal to 1, 1 minus 1, 0. 1 minus 2, minus 1 I'll get. How this point is clear. Similarly, if I take n is equal to 2, 2 minus 1, 1, first term, okay. But 2 minus 2, 0, 0th term, no. The location will start from 1, first term, second term, third term, moves on, okay. Now here, even though they asked us to find third term, we start with second term. Reason very simple, same like the previous problem. See, if I put in this equation number 1, directly 3, put n is equal to 3 in equation number 1, we are going to have a3 is equal to 3 minus 1 plus 2. 3 minus 1 is 2 plus 2. Second term I want. Second term from here, that's what we are finding. A1, first term is 1. 1 plus 2 will be 3. This is actually called recurrence relation type problem, where you are going to have some relation. Okay, both the sides you have got a term location. Now the second term is 3. So I can just put here 3 plus 2, nothing but 5. So the third term is 5. So fill in the blanks. Answer is, kindly make a note of this. Yeah. Dear students, having understood the first concept, that is about the location of the term, the sequence concept, and then solving the 3 problems from model question paper, now comes the next concept, that is geometric progression. Now what is this geometric progression? Geometric progression or sequence. See carefully. What is geometric progression? It is a progression which is written with some particular rule, such a way that we can get the next term by multiplying a particular constant. What's the meaning of that? Just see carefully one example. Let us understand with the help of example. 2, 4, 8, 16, 32. See carefully this. 2 into 2, 4. 4 into 2, 8. What is that again? If I multiply 2 to this, 2 to the 4. 4 into 2, 8. 8 into 2, 6. 6 into 2, 32. So I am getting the next set of elements by just multiplying a fixed constant. And this 2 is not because of this 2. No. Let me give one more example. 1, 5, let's just say 25, 125, and so on. So just see here. To get next 1 into 5, 5. 5 5s are 25. 25 5s are 125. So here I am multiplying a fixed number 5. Only you cannot multiply 0. Okay. Why? Let us understand. First, before going to that, let us understand this. As per the location of the term, this is my first term, this is my second term, third term, fourth term, fifth term. Now coming to this, see carefully. Now how to obtain this common constant? See, this is the second term, the first term. So if you just take the ratio of second term and the first term, second term is 4 and the first term is 2. 4 by 2 is 2. Next again, if you take third term ratio with second term, third term is 8 and second term is 4. So 8 by 4 will be 2. Again you see here, fourth term, that is this, by third term. What is fourth term? 16 and third term 8. 8 2s are 16. Thus we can divide, no? 2 1s are 2 2s are, 4 1s are 4 2s are, 8 1s are 8 2s are. So what we can see, we are taking consecutive ratio, term by its previous term, second term by first term, third term by second term, fourth term by third term. Nothing but ratio of two consecutive term, but here order is important. Term by its previous, term by its previous. Should not be a reverse of that. That no, you have taken the previous term divided by present term. No. Term by its previous, term by its previous, and we are getting a common number, and this we call common ratio. This we call common ratio, and which we done by R. So common ratio is 2. And how to obtain common ratio? The common ratio is given by ratio of the term and its previous, second term by first term, then third term by second term. Always, whenever they ask us to check whether it is in GP or not, we are going to just see whichever number of terms are given. If I take the ratio by its, I mean to say ratio between the term and its previous term, I should get a common number. Only then we say it is geometric progression. Similarly, you see here that as per the location, this is my first term, second term, third term, fourth term, and moves on. Now, if I take second term by first term, it is 5 by 1, nothing but 5. Next is third term by second term. Third term is 25 and second term is 5. So I'm going to get what? 5 1s are 5 5s are nothing but 5. And here anyway 5 by 1 is 5 itself. Next, if I take fourth term by third term, fourth term is 125. Then by 25, simplify here. By 5 table, let's say 5 5s are 25. Here 5 2s are 10. Borrow 5, 5 4s are 25. 5 and 5 gone, so it will be 5. So here again you can see common ratio is obtained by term, second term by first term, third term by second term, lastly fourth term by third term, and all are equal to what? 5. Therefore the common ratio of this is what? 5. Let us suppose a particular term is present where the common ratio is not same, nothing but the ratio is not same, then it's not in GP, it's not a geometric progression. I hope this point is clear. Now, one thing, R, here it is more than, here it is R positive, here also R positive, R can be negative also. Let us take one example on that. Should not happen, no, that you are taking away that R can't be negative. Elements can be positive also, negative also. So first term, second term can be positive, negative. Common ratio also same. So for example, third question, let's suppose one example. So let's have 1 minus 3, 9 minus 27, okay, and so on. Just see carefully. This is the first term, second term, third term, and here fourth term. So common ratio. First, let us find this condition. Then we should say common ratio R is existing. So here A2 by A1. Okay. What is second term? Minus 3. First term 1. So it is minus 3 here. Similarly, A3 by A2. Third term is 9. Second term is minus 3. Plus or minus is minus. 3 1s are 3 3s are. So I'll get minus 3. Next, what is fourth term by fifth term? Sorry, fourth term by third term. Fourth term is minus 27 and third term is 9. So here very clearly 9 ones are 9 threes are, so I'll get minus 3. So you can see common ratio is minus 3. So always a constant, the ratio is always constant. Therefore, the common ratio is minus 3. So common ratio can also be what? Negative, need not be positive. But common ratio cannot be 0. How, sir? See this one example we take. If we'll take one term like this, I want common ratio. Okay, we'll have a feeling of 1 into 0 is 0, 0 into 0 is 0, 0 into 0 is 0. But when I want to find the common ratio, this is my first term, this is my second term, this is my first term, then this is my third term, this is my fourth term. See that a2 by a1, a2 is 0, a1 is 1, 0 by 1 is 0. Now see a3 by a2, a3 is 0, a2 is also 0, 0 by 0. This is not a real number. This is not a real number. As mentioned like this, it's not a real number. Whatever we are getting, the answer is a real number so far. So you cannot have something like this. This is not a GP, not a GP. In short, for geometric progression, we said GP valid. Okay. Whenever you see in question paper also, GP is understood geometric progression. So I hope this concept is clear. Now let us try to also understand this in general form. First, kindly make a note of this. Okay. Now let us move on to the general form of a GP. So general form of a geometric progression. See, for any sequence, there are two things required for GP. Same like your arithmetic progression in school days. First term and common difference there. Where as soon as you know first term, we are going to add a fixed number to get the consecutive terms. Similarly here also, first term, let us suppose A. The next term to obtain, I have to multiply a common ratio R. R is what? Common ratio. Which is non-zero. It can be positive, negative, but not zero. So A into R, AR. Again multiply R for this. R into R will be R square. So AR square. AR square into R will be AR cube. Like this it moves on. Now this will be a finite sequence. Now I would like to know what was the last term. For that, first see this. This is my first term A1. This is my second term A2. This is my third term A3. This is our fourth term A4. I want the last term here, that is nth term. Let us write equal sign only, no problem. Nth term. Now see the pattern. Can you see for all A is there? So it means my last term will have definitely A. Then you can see very carefully, R is actually present here also. I can just say this one as A into R power 0. Okay, now R power 0 is 1, 1 into A is A. So just see the index and power of R. Here the index is 1, power of R is 0. Here the index is 2, power of R is 1. Here the index is 3, power of R is 2. Here the index is 4, the power of R is 3. Whatever index is there, power is just 1 less. Correct, no? So 3 minus 1, 2. This is what? I can say as 3 minus 1. What is this? 4 minus 1. What is this? 2 minus 1. So nth term. So when I write R here, whatever index is there, the power is just 1 less than that. I am mentioning in the bracket so that it's very clear that power of R is n minus 1. Okay. Therefore, my nth term of a geometric progression will be an is equal to a into r power n minus 1, where a, which is actually a1, both are same, that a1 or a, both are first term. So this formula we have to memorize. When to use this? Whenever I want a particular term. As soon as I know nth term, I can find whichever term I want. For example, here put n is equal to 5, fifth term. Put n is equal to 7, seventh term. But surely n is always what? A natural number, as we discussed previously. Because counting It gives the location of the number, so always start from 1. Natural number it is. Next, R is what? Common ratio, which is given by A2 by A1 is equal to A3 by A2 is equal to A4 by A5, sorry, A3, and moves on. Okay, when I say moves on means whatever number of elements are there, for all this condition, whichever I take the ratio between the term and its previous, it should be same. Okay, this we call common ratio. Common ratio. Ratio we are taking, and it should be what? Common. Next, n stands for number of terms, and number of terms cannot be negative nor fraction. It should be always a natural number. Number of terms. And this an. Okay, nth term we say there are some other name, let us write it here. Nth term or last term. Last term or general term. All mean the same. Whether it is general term, last term, or nth term, for all it is the same, and this will be useful. As soon as I know the nth term, I can find whichever term I want. For that, I want first term and common ratio. Anyway, when I say fifth term, n equal to 5, seventh term, n equal to 7. Okay. Now, next concept: how to find the series. See, we have been talking about the term. Let us suppose that I have got a GP, that is this, and I want to find the sum. So sum of first n terms of a GP. TE it is. Okay, I'll write it properly. It will be Sn is equal to A into 1 minus R power n divided by 1 minus R whenever common ratio is less than 1. Mod of that. Actually, if I take negative common n, no, I'll get one more formula, that is A into R power n minus 1 divided by R minus 1, where mod of R is more than 1, but both will give you the same answer ultimately. It's not a big difference that if you are going to use this, if this condition is violating, you will get some other answer. You will get ultimately same. Just see carefully what has happened here. If I take negative common, here, just see. If I take negative common, let I will put here. If I take negative common here, so A as it is, okay, A, okay, negative if I take common, A as it is. See carefully, minus into minus is plus R power n, minus into plus is minus 1, divided by, again here, negative out, minus into minus will be plus, minus into plus will be minus. So negative gone. Ultimately what we got? This. So both are same only. Next, see here I have given strictly less than and strictly greater than. Nothing but what if R is equal to 1? This formula will fail, because if R equal to 1, R is 1 here. 1 power n is 1. 1 minus 1 will be 0. 1 minus 1 will be 0. 0 by 0 form. So if common ratio is 1, then the sequence, this sequence in form of a series will become, see, put R wherever R is there, put as what? 1. So we get what? A. Okay. Then A plus A plus A moves on A. How many times? Here we have how many terms? First, second, third, up to n terms. So we have n terms here. So I'll just go to one school days logic. What is A plus A? What? 2A. What is A plus A plus A? It is 3A. Why it is 3A? A is added how many times? 3 times. Or A is there, how many terms are there here which is repeating? N times it is repeating. So 3 times it is repeating, so 3A. 2 times it is repeating here, so 2A. Here it is repeating n times. So it should be what? NA. Okay, so I hope you understood that if common ratio is 1, no problem. We are not going to use this formula nor this formula, but it will be n times of the term which is being repeated n times. Okay, fine. So with this, some part is completed. We'll take one last concept, geometric mean, and then we'll start with the problems. Kindly make a note of this. Okay, now it is, dear students, now let us move on to geometric mean. Now what is this geometric mean? In short, we are going to write GM. Okay. Now let us suppose that we have got two numbers A and B such that both are positive. See, for derivation part, as per the textbook, both are positive, but it can be negative also. Both are negative also. Okay, but it can't happen. One is positive, other is negative. Okay, either both should be positive or both should be negative. Let me take that. Now, I want to insert between A and B. I want to insert a number. Let us suppose the number is G, such a way that these three numbers form geometric progression. Nothing but common ratio should exist. So since we have three numbers, the location of this is first term A1, this is the second term A2, and this is the third term A3. So since it should be in GP, so the condition common ratio should exist. Nothing but second term by first term should be equal to third term by second term. Second term is G, first term is A, third term is B, second term is G. So I want to find this G, which is a term such a way that if I write A, G, B, it should be in geometric progression. Now see, cross multiply, solve for G. What will be G into G? G square is equal to A into B. Or G is equal to plus or minus root of A into B. Now since A and B are inside the root, the reason either both A and B should be positive or both should be negative. Otherwise, we'll get imaginary. Okay. So having understood this, let us take one problem on this and then we'll go ahead with model question paper problems. Kindly make a note. Okay. Dear students, before taking up the problem on geometric mean, the last concept, relationship between arithmetic mean and geometric mean, let us take. Okay. This will be our last concept, relationship or relation between arithmetic mean and geometric mean. Okay, between two, this time we take positive numbers, two positive numbers, between two positive numbers A and B. See, from school days, we know that coming to arithmetic mean, if I take arithmetic mean as capital A, the arithmetic mean between these two numbers is A plus B by 2, equation number 1. And now we just learned that geometric mean between the two numbers is G is equal to square root of AB. I'll just take positive value. Okay, second equation. Now let us consider the difference of these two. Let us consider the difference of these two. A minus G is equal to A is A plus B by 2 minus G. Is it not this is same as root A into root B? So I can just substitute root A, root B. Nothing means 1. LCM of 2 and 1 is 2. So 2 by 2 will be 1. 1 into A plus B minus 2 by 1 is 2. 2 times of root A, root B. Okay. Now let us try to see carefully. Can't I use the formula A minus B whole square? Just see this. What is A minus B whole square? A square plus B square minus 2AB. See carefully. Here whatever term is there, the square of that should be there. See carefully here. Let us write again. Is it not? Since I have got root A, this will be root A the square. Since I have got root B, this will be what? Root B the square. And I give plus a bit more separately. Root B the square plus as it is. Now you can see that square root and square will get cancelled. I'll get A. Square root and square will get cancelled. I'll get only B. That's what you can see here. It resembles this formula. So I'm going from right to left. So in place of A, we have root A. In place of B, we have root B. So we can rewrite this entire thing. And you can see AB, nothing but root A, root B. So the right hand side is root a minus root b the whole square divided by 2 as it is. Now since you have got the square, nothing but power is even though we have minus the quantity, if root b is larger than root a, this can be negative. If root a is larger than root b, it can be positive. And if both are equal, it can be 0 because we have got minus sign. If both are same, both will get cancelled because signs are opposite. So ultimately, the value of this is non-negative. Nothing but either greater than 0 or equal to 0. That is about left hand side is a minus d. Don't forget, it's always what? A minus d. A minus g. So what we understood, see from here to here, arithmetic mean, difference and geometric mean. Difference between arithmetic mean and geometric mean is always non-negative. If I transpose this, arithmetic mean is always greater or equal to geometric mean. What is arithmetic mean? A plus b by 2. What is geometric mean? Root of ab. If I cross multiply, we will get this a plus b greater or equal to 2 times of root a b. Now one thing to be understood, I have given equality. Equality will hold provided a and b are same. If a and b are same, both will get cancelled. Correct? No. So let's write as a note. Note equality holds. Equality holds if a and b are equal. Okay, equal. This means small. Yes. So with this, all the concepts are done, and this will be one of the important results for us, that arithmetic mean is always greater than or equal to geometric mean. Equality will hold good provided the numbers are equal. Whenever they are unequal, it will be always strictly greater than. So with this, we are ready for the problems from model question paper. Kindly make a note of this. Okay. Dear students, before going to model question paper problems, let us take a problem from exercise 8.2 on geometric mean. Question says, for what values of x the numbers minus 2 by 7, x minus 7 by 2 are in GP. When I was deriving the result, that is expression for geometric mean, I said a and b can be both positive and a and b can be both negative. That's what you can see here. Between these two numbers, I have to get x such a way that it is in GP, nothing but geometric progression. So if we just go to that concept, this is our a, this entire thing is g, this is our b. So we know that g is equal to plus or minus square root of a into b. A one marker question we can say. So now let's substitute plus or minus root of a value minus 2 by 7 into b value minus 7 by 2. Okay, without any trouble. 7 will get cancelled by 7, 2 by 2 will get cancelled. So what is remaining? Minus to minus is plus. So g is equal to plus or minus root of 1. What is root of 1? And g, what is g here? X. So x is equal to plus or minus 1. Okay, that's it. Now let us move on to model question paper number 1. As we know that this all papers are issued in this academic year, and that's what I am taking all the problems from this from PU board. Question number 27. It's a 2-marker question. Question says from model question paper number 1, in a GP, nothing but geometric progression, the third term is 24 and the sixth term is 192. Then find the 10th term. Always decode in math language. See carefully. Third term means A3. Is means equal sign. 24. Okay, 24. Next what? Sixth term is 192. Sixth term A6. Is means equal sign. 192. Then what? Find the 10th term. A10 is the question mark. My suggestion, always start from here so that you understand how to use this data. Now you see, since they are talking about a particular term, so I have to use that nth term concept. Recall, nth term formula is a into r power n minus 1. So in place of n we have 10. So this will be n is equal to 10 here. So tenth term is a into r whole power 10 minus 1. Until and unless I don't know what is a value and r value, I cannot get the answer. I hope this point is clear. That's the reason they gave two information. Now here this is third term. In this formula, wherever we have what? N put as 3. Just see carefully what we are going to have. So a into r, in place of n 3, n is equal to 3. So I'll get 3 minus 1 in the power is equal to 24. Nothing but a r square is equal to 24. Okay. Now come to the sixth term. So here n value is 6. Put n is equal to 6. So this will become a into r power 6 minus 1 is equal to 192. So a into r power 6 minus 1 is 5 is equal to 192. Now, don't think, no, there are two variables, two unknowns, that is a and r, how to solve, it's non-linear, etc. Just chill, can't you think of dividing this? This I will take as equation number 1. This I will take as equation number 2. See, since I first solved this and we came to know a and r are unknown, until unless I don't know the value of a and r, I cannot proceed. So when you go like this, no, you'll understand how to use the data and for what the data is given. Now, if I just divide, what's the reason to divide? If I divide, no, a and a will get cancelled. I'll have only one variable. So either you can divide 1 by 2 or 2 by 1. Left to your choice. I will prefer to divide 1. Reason, see carefully. When I say divide, left with left, right with right hand side. A r power 5 divided by a r square is equal to 192 divided by 24. 192 divided by 24. See the advantage of dividing 2 by 1. The unknown r is there in numerator. So here 3. How 3, sir? When you think of dividing, no. See carefully. What laws of exponent says? What is a power m divided by a power n? A power m minus n. So r power 5 by r power 2, if I take r power 5 minus 2, that will give you r power 3. I hope this point is clear. Now simplify this. Let's say 2 tables. Okay, I think 4 will be better. A bit common, I mean to say, when I'm dividing, let us take a big number so that the division will be a bit faster. 4 7s are 24. Okay, but here 4 4s are 16. 5 6 7, okay, 4 4s are 16, 17 19. Okay, 3 here. 4 8s are 32, and here 4 6s are 24. Next, when I divide again here, 4 1s are 4 2s are, and here, okay, 4 is not possible here, you can see, correct? So I will change the divisors from 4 to 2. So 2 2s are 4, 2 4s are 8, and then here 2 3s are 6. Anyway, I could have divided by 6 only. Anyway, 3 1s are 3, 7s are 3, 8s are 24. So we have got r cube is equal to 8, or r is equal to cube root of 8. What is cube root of 8? 2. Only real roots we want. Now I also want which value? A value. So either I can put in 1 or 2. I will put in 1 because here the expression is smaller, so my simplification will be smaller. So if I'm going to put this in equation number 1, we are going to have a into r power 2. R value is 2. And then we have got square is equal to 24. Square is equal to 24. What is 2 square? 4 is equal to 24. Now from here, 4 1s are 4 6 are 24. A is equal to, A into 1 is A is equal to 6. So A is equal to 6 and R is equal to 2. Now we can put all this in this expression to get the final answer. This is our equation number 3. So put in equation number 3 what we are getting. 10th term is equal to A value is 6, R value is 2, and here 10 minus 1 will be 9. Multiply 9 means multiply 2 9 times, we'll get 5 and 2. Now multiply this, 6 2s are 12, borrow 1, 6 1s are 6, 7, 6 5s are 30. So the 10th term is 3072. 10th term. That's it. Okay, kindly make a note of this. Yes. Dear students, we are ready for the 4-marker question. Now, don't forget, in 4-marker, you can also go for derivatives or this, anyone, correct? Let us move on. Question says, find the sum of the series up to n terms. See this, check. Is it in geometric progression or not? 5 plus 55 plus 555. The pattern will move on nothing but the next. See, in the first term there is only 1 5, second term there is 2 5, third term there are 3 5, fourth term there will be 5 4 times, and it moves on, and I want up to what? N terms. When they said n terms, it's very clear that it's a finite series. Is in GP. Many will think it's in GP. No, it is not. Why? Check this. 55. As you know, this is our first term, second term, third term, fourth term moves on. Find the ratio of second and first. 55 divided by 5 will be 11. 5 ones are 5 11s are. But A3 by A2 when you do 555 divided by 55. Check it out. This will not be equal to 11. You will be saying, sir, 10 point something you are getting, so it is approximately equal to 11. No, we want exactly equal. We never said approximately equal. Therefore, this is very clear that the given series is not in GP. This entire thing is what? Not in GP. Then how are we going to solve this? On this, we have got other problem also, where in place of 5 we have 7, where in place of 5 we have 8. That will be assignment. Okay, those are also important. Now listen carefully. How are you going to solve this? Ready? Focus. Since I want to find the sum, so I will take, let's start from here. Sn, I will take sum of all this 5, 5, 5, 555, and so on. Up to where? N terms. Correct now? Now what we will do, listen carefully. Take 5 common. If I take 5 common, 5 1s are 5 plus 5 11s are 55. Okay, then 11 times, and here number of term. And some will have a doubt, sir, should I write here divided by 5 because I'm taking 5 common. This stands for what? Count of the number of terms. So whether I add or subtract, this will not affect. This only gives the count of number of terms, nothing else. Now what we will do? Multiply. Just listen for a minute, okay? Multiply and divide by 9. Just after 2 more steps, it will be very clear why we are doing this step. Okay? As soon I divide and here multiply, 9 into 1, 9, 9 into 11, 99, 9 into 111, plus up to what? N terms. Like this I have to do for N terms. Now see carefully, can't we rewrite this 9 as 10 minus 1? Can't we rewrite 99 as 10 square minus 1? Can't we rewrite 999 as 10 cube, nothing but what? 1000 minus 1. Like this, my last term, follow the pattern. See the pattern, focus the pattern. Here 10 minus 1. Here 10 square minus 1. Here 10 cube minus 1. So this is what? First term. What is this? Second term. What is this? Third term. And now I want what? Nth term. I want what? Nth term. So see the pattern. Power of 10. Here, power of 10 is 1, no? So the power of 10 and this index is matching. See here? A2 10 square, A3 10 cube. So 10 power n. Then what? Minus 1 for all. Okay, minus 1. Is this logic clear? How I wrote the last term? I just saw that my index and the power of 10 are matching. Index is 2 here, power of 10 is 2. Index is 3, power of 10 is 3. Similarly, index, since I want last term, index is n, so it should be n here. Minus 1 same. Now what we are going to do? We are slowly trying to convert to GP now. Let us try to collect all. First 5 by 9 as it is. Let us try to collect power of 10 separately, 10 power 1 plus 10 power 2 plus 10 power 3 as moves on 10 power n. So 10 power 1, nothing but 10, then 10 square, then 10 cube, and moves on up to 10 power n. Then what? Next line, right? Plus of what we have, minus 1, minus 1, minus 1, moves on minus 1. So what happened? Minus 1, minus 1, minus 1, ultimately minus 1. Okay. And now see carefully, this is in GP now. This entire thing is in GP, geometric progression. House cell, check it out. First term is 10, no? So A2 by A1. So now this in this, not in this entire now. Now I'm talking about that step. Now we can see that this is our first term, this is our second term, this is our third term, and so on. So second term is 10 power 2. First term is 10. So I'll get what? 10. Because 10 square is 100. 100 by 10 is what? 10. Now you see again, A3 by A2. Or third term, 10 cube divided by 10 square. Again, law of exponents, or you can simplify both the ways. Ultimately, you get what? 10 power 1, nothing but 10. Common ratio exists, therefore it's in GP. Now for GP, what's the formula for sum? Sum is A into R power n minus 1 divided by R minus 1, where mod of R should be more than 1. Yeah, common ratio is 10 and 10 is more than 1. So first term in this is 10. Common ratio is also 10, which is more than 1, and number of term remains n only. So only for this we are applying the formula. So 5 by 9 times of A. What is A? 10 into R. What is R? 10. N remains m because question said find the sum up to n terms. Minus 1 divided by R minus 1. R is what? 10. So 10 minus 1. I hope you are clear. So we have found the sum of this. Now I want the sum of this. We also discussed, see, all are same. Recall what is A plus A plus A, ultimately n times. N times. What is the value? NA. So here what do we have? Minus 1, minus 1, minus 1. How many times? Come back here. Each of this minus 1 has come from each of the term here. First term also, second term also, third term also, and the last term also. So very clearly, this minus 1 present how many times? N times. So in place of A, we have minus 1. So it will be plus as it is n times of A. A is our minus 1. And how many times are there? N times. Simplify. Finally, the sum is 5 by 9 into 10 times of 10 power n minus 1. 10 minus 1 is 9. Plus into minus minus n. So this is our sum of n terms. With this 4-marker question done, as an assignment, you can take the problem, 2 assignments. One is 8 plus 88 plus 888 and so on. And one more assignment you can take 7, 77, 777. Both are NCERT problems. And again important for 4 mark. If you just see here, wherever 5 is there, if I take the first problem that is 8, wherever 5 is there, you have to replace by 8 throughout. Mean to say only this multiple will change. In place of 5, what you are going to have for the first problem? 8, 8, 8, everywhere 8. And for this second problem, in place of 5, it will be 7. The term which are present here inside the bracket, here also inside the bracket, will not change. Okay, apart from this first. Anyway, as soon as you take common, everything will flow the same. Okay, kindly make a note of this, and this is a 4-marker question. Kindly make a note. Yeah, this is SN. Okay, now completely. Dear students, let us move on to the next problem from the model paper number 2. From part B, 2-marker question, question number 25. Question says the sum of first three terms of a GP is 13 by 12 and the product is minus 1. Find their common ratio. So from here very clearly common ratio they said, so find R. And the terms, I want those terms, those 3 terms. Don't forget to find term. No, as soon as I know first term, to get the next term I have to multiply common ratio. So first term is required. So because they said find the terms very clear from here, I have to find the first term also. I hope the point is clear. Now, surely majority of the students will be thinking the first three term will be a, next term is ar, and one more is ar square. Just by multiplying r to the first term we got ar, again multiplying r here we got ar square. But whenever you have problem of sum of 3 and product of those three number is given, some data is given, don't choose this. Choose some other. What? Listen. When you want to go front, no, you should multiply common ratio, correct? Yeah? But if you want to come back, you should divide by r. See, ar square by r will be ar. Ar by r will be a. So what could be the term before this? Divide by r. So I'll get a by r. So what I mean to say is, we will be choosing the terms to be this. There is an advantage. What? Listen carefully. So now let I remove this part. Okay. So I'll be choosing a by r, a and a into r. I just gave a no idea how we are getting this. Then I remove this now and just write down whatever the term just now I said and see the advantage. So let the terms be a by r, a into r. Now, as per the question, sum of the first three terms is 13 by 12. So sum this. Sum of that is a by r plus ar is 13 by 12. And they said their product. Come on, take the product of this. A by r into ar is equal to how much? -1. Now see carefully. Since I took the product in this form, r by r will get cancelled. R by r will get cancelled. A into will be a cube is equal to -1. If I take cube root of -1 will be -1 itself, which is a real number. Now put this value in equation number 1. If I put in 1, we are going to have, in place of a, it is -1. So we are going to have -1 by r plus a is -1, then again -1 into r is equal to 13 by 12. Let's simplify -1 by r as it is. Plus into -1. And -1 into r will be -r is equal to 13 by 12. So here 1, here also 1 I can say, because nothing there denominator. Whenever there is nothing in denominator, it is 1, because number by 1 will be always the, I repeat, number by 1 will be always a number itself, the same number. 2 by 1, 2, 3 by 1, 3, a by 1, a, r by 1, r. Okay. LCM of r1 and 1 will be r. It's not writing. R by r will be 1. Multiply here in the numerator. 1 it is 1 -1 into 1 will be -1. R by 1 will be r. So multiply here. -1 into r will be -r. R by 1 will be r. So multiply r here. So I get -r square. What we do usual LCM, same thing I have did here. I have shown the steps, nothing else. Now I can cross multiply. All are fine. Okay. Now when I cross multiply, I'll get -12 is multiplied here, so I'll get -12, then -12r, then -12r square is equal to 13r. Transpose every all terms this side. We are going to have plus 12r square plus 12r plus 12 plus 13r is equal to 0. 12r square is then 12r plus 13r will be 25r plus 12 is equal to 0. We have to factorize here. So since it's a quadratic, how we are going to factorize? R square multiple and the constant multiply, 12 to 12 will be 144. Let us try to get the factors here. Start dividing by a smallest prime number, that is 2. So 2 7s are, 2 2s are, then 2 3s are, 2 6s are, 2 1s are, 2 8s are, and then here 3 3s are 9 or 2 9. Okay, 3 6 are no, or 2 9s are 18, and then 3 3s are. So 3 3s are 9. So I have to find the factors. You can see here 2 2s are 4, 4 2s are 8, 8 2s are 16, 3 3s are 9. 16 and 9 together will be 25. Yes, we have got the factors. It is 16 and 9. So 12r square plus recording no. 16r plus 25. I mean to say it is a 9 no. 9r plus 12 is equal to 0. Here common is 4r, right? So because 12 and 6 common is 4, r square r common is r. So 12 by 4, 4 3s are 12, then r, then 4 4s are 16, then plus here common is 3, so 3 3s are 9, then 3 4s are 12. So as you can see, common is 3r plus 4 into 4r plus 3, 4r plus 3. So from here, product of two terms is equal to 0. Anyone should be equal to 0. So we'll be having 4r. I mean to say 3r plus 4 is equal to 0, or 4r plus 3 is equal to 0. From here solve for r. So 3r is equal to minus 4, or r is equal to minus 4 by 3. Or from here transpose this, 4r is equal to minus 3, or r is equal to minus 3 by 4. So we have got two common ratio, nothing but we have got two GPs. For both the GPs, first term is minus 1. So don't forget a is equal to minus 1, or here also a is equal to minus 1. They said to find those terms, nothing but I have to substitute in the terms which we have assumed here. Okay. So let's say, since I have said equation number 1, no. Okay, I'll call this as equation n for Naseer Ahmed. Okay. So no problem. So if I put this all value in equation number n, what's going to happen? I think space is not sufficient. First you make a note. I want to raise the question. I hope you have made a note. Okay, see carefully. So first we are putting on the side again, a is equal to minus 1, a is equal to minus 1, and r is equal to minus 4 by 3 in equation number n. I am substituting, that is a by r. What is a? Minus 1, r is minus 4 by 3, negative will get cancelled, 3 will jump up, so I'll get 3 by 4. Then I have a is equal to minus 1. Then we want a into r. Okay, find a into r. So what is a? Minus 1. And what is r? Minus 4 by 3. Minus 1 is plus. I'll get plus 4 by 3. I hope this is clear. Fine. Now similarly, if I put this value, which is that a is equal to minus 1 and r is equal to minus 3 by 4. If I put again in equation number n, so see carefully what's going to happen. With more space. So see, equation number n, here a by r. What is a? Minus 1. What is r? Minus 3 by 4. Negative will get cancelled here. 4 will jump up. I'll get 4 by 3. Then it is a. What is a? Minus 1. Then it is a into r. What is a? Minus 1 into minus 3 by 4. Minus minus plus, I'll get 3 by 4. Okay, so let's conclude. Therefore, the terms are if I take this category, that first term is minus 1 and common ratio is minus 4 by 3, my terms are will be 3 by 4, then minus 1, and then 4 by 3. And one more, or I can say or better, or it can be first term is 4 by 3, for second term is minus 1, third term is 3 by 4. You can just see both are actually same. It is whatever the numbers is there, right to left. Now it is left to right. And we also discussed that now we can have alternate series also if common ratio is negative. You can see it's alternate series. So, dear students, let us move on to the next question from model question paper number 2, 4 marker, question number 47. If arithmetic mean and geometric mean of two positive numbers a and b are 10 and 8 respectively, then find the numbers. Solution. Since they said the numbers of these two, arithmetic mean and geometric mean, is formed, and we want those two numbers. So A and B both are question mark. Arithmetic mean between these two numbers is given by A plus B by 2, and that they have given arithmetic mean, they are given as 10, so is equal to 10. Geometric mean, we know it is square root of A into B, and that geometric mean they have given as 8. The word respectively says first with first, second with second. Okay. Now we have to find those two numbers. Fine. Now let us proceed. If I cross multiply this, we are going to have A plus B is equal to 20. And if I squaring on both the sides, on squaring both the sides, we are going to have AB is equal to 8 square will be 64. So this is our equation number 1. And this is our equation number 2. We have to find A and B value. Okay. See, we can go for substitution method also. I can just solve for B here and substitute here, and then we'll get a quadratic. That will be one method. Do we have some other? Just see. With more faster type than the usual method. If I try to get somehow A minus B, then I can go for elimination method easily. Because here if I cross multiply, no, I will get a fraction. I have to go for some more calculation if I go for usual method of substitution. So what we can do, just see carefully. We know that A minus B the whole square is equal to A plus B the whole square minus 4AB. Check it out. Minus 4AB. This will be what? A square plus B square plus 2AB. Plus 2AB minus 4AB. Let us write for you. Let us make you understand how this is same. This will be A square plus B square plus 2AB minus 4AB as it is right hand side. Then I will get A square plus B square, and this will be what? Minus 2AB, which will be what? A minus B the whole square. That's the reason these two are what? Same. Now what is the benefit of this? See the advantage. Listen carefully. A minus B square I want to find. Now from here, A minus B the whole square is equal to A plus B is 20. So put there 20 square. Minus 4 times of A into B is 64. So in place of A into B 64. 20 square will be 400 minus 4 4s are 16. 6 4s are 24. 25. Right now 25. 256. Now simplify this. So on subtracting this, we get 144. A minus B the whole square, or I can say A minus B is equal to plus or minus 12. Not only plus 12, plus or minus. Now we have got addition, we have got subtraction. Now we are going to solve this separately. So now see carefully. Solving what? 1 and 3. What is 1? A plus B is equal to 20. And 3 is A minus B is equal to plus 12. Similarly, A plus B is equal to 20. And from here, A minus B is equal to minus 12. Okay. Now by elimination method, plus B minus B will get cancelled. A plus A will be 2A is equal to how much here? 32. So simplify 2 1s are 2. 16s are. So A is equal to 16. So it is, this is our equation number 1. No. So if I substitute, because this is same as here. So if I put in equation number 1, we get 16 plus B is equal to 20. B is equal to 20 minus 16. B is equal to 4. We want those two numbers? Yes, we are getting. Similarly, for the negative 12, so again, if I go for elimination method, B minus B will get cancelled. A plus A will be 2A, and 20 minus 12 will be 8. Now here 2 1s are 2 4s are. So A is equal to 4. Now if I substitute again in 1, if I put in equation number 1, we are going to have A is 4, then plus B is equal to 20, or B is equal to, transpose this, 20 minus 4 will be B is equal to 16. Ultimately numbers are same, you can see they just got exchanged. Therefore the numbers are. Therefore, numbers are 16, 4, odd 4, 16. I hope this is clear. Kindly make a note of this. Okay. Dear students, let us move on to the next problem from model question paper number 3, a 2-marker question. Question says, arithmetic mean and geometric mean of roots of quadratic equations are 8 and 5 respectively. Then find the quadratic equation. Before I go to the problem, let us just give you a formula. How are you going to find quadratic equation if the roots are known? See carefully. One note I will give here. If m and n are the roots of a quadratic equation, then the quadratic equation is given by x square minus sum of the root into x plus product of the root is equal to 0. So if m and n, if I know the roots of a quadratic, as we know in quadratic we have degrees 2, so there are 2 roots. Let us suppose the 2 roots are m and n. Then the quadratic equation given by x square minus sum of the root into x plus product of the root is equal to 0. Now, having this background, we are going to solve this problem. They are saying arithmetic mean and geometric mean of roots of quadratic equations are this. Let us suppose that I can say the roots be a and b. So they are saying arithmetic mean is 8 and geometric mean is 5. But we know arithmetic mean between these two numbers is given by a plus b by 2 and geometric mean is given by root of a into b. So since you can see now a and b are the roots, no? So I want sum of the root and product of the root. So I can cross multiply 2 here. So I'll get a plus b is equal to 8 2s are 16, and here on squaring both the sides. On squaring both the sides, we will get AB is equal to 25. So now quadratic equation given by quadratic equation is x square minus sum of the root into x plus product of the root is equal to 0. X square minus sum of the root is 16. So 16 times of x, product of the root is 25. That's it. With this, we get the quadratic equation. They want quadratic. So for this, you have to remember this result better. Now memorize that. With this problem done. Okay. Yes, dear students, we are with the last problem from the model question paper, a 4-marker problem from model question paper number 3. Question says the sum of first 3 terms of a GP is 16 and the sum of next 3 terms is 128. Determine the first term and the common ratio. Determine the first term and the common ratio. From here nothing but A, and this is saying we have to find R. Okay. Now let us try to go with very elementary level. Sum of first 3 terms of a GP is 16. Nothing but first term, then second term, then third term. How much? 16. Then sum of next 3 terms. See, after third, which is the next term? Fourth term. This is and. Okay. Next 5, then 6 is how much? 128. Okay. Now see, first term is A, second term multiply R to this AR, third term multiply again R to this AR square is equal to 16. Now for this third, this is fourth term, no, multiply R to this AR cube. Again, multiply to this. Or in short, whatever the index is, the power will be 1 less than that. Correct? Now here power is 5, so it will be 4. Again here power, here index is 6, so it will be, since index was 5, power is 4. Index is 6, power will be 5. You can just recall the formula for nth term. An is equal to A into R power n minus 1. Now see carefully. I have to just do some manipulation and get the answer very easily. If you say this, I will try to express left hand side in terms of this left hand side. If I take R cube common here, why? Here there is no R. So if I want to remove this R cube, so if I take R cube common, you will get A. Then here you will get AR. Then here you will get AR square. Now see carefully. This I will take as equation number 1 that is present here. Correct? So R cube into 16 is equal to 128. Now let us simplify. Cross multiply this. R cube is equal to 128 divided by 16. Now we have to simplify. Let us simplify by 2 table. Okay, 4 will go. 4 3s are 12, 4 2s are 8, then 4 4s are 16. 4 1s are 4 8s are 32. So R cube is equal to 8. Or we can just say that R will be cube root of 8. What is cube root of 8? 2. Because if you multiply 2 3 times, I will get 8. I want next what? First term. Now to get first term, either I can put in equation number 1 or in this also. But this is a bit lengthy in working than this because we have got different powers for R than this. So if I put in equation number 1, we are going to have A plus A into R. R is 2. So 2 times of A. Then again R is 2 with a square. So A, then 2 with a square is equal to 16. So we are going to have A plus 2A will be 3A. Then 2 square is 4A is equal to 16. 4A plus 3A will be 7A is equal to 16. Or A is equal to 16 by 7. We got this also. And we got common ratio, that is 2. That also. So both we have got. That's what they asked. So kindly make a note of this. Yes, dear student, with this we have completed the chapter sequence and series. Not only that, we have also completed this crash course. Okay. So with this, I would like to know how many of you have taken this opportunity and grab in both the hands and ace your marks. Okay. Let me know after the result is announced, after your final board examination of first year PUC. So all the very best. Do well, study well, and God bless you all. Lastly, do share, like, and subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you.